Alright, now looking at 7D.2. We are now solving for the missing angle. So in D1 we were solving for a missing side. Now we don't know what one of our angles is. Okay. I can solve for the missing angle of a right triangle by setting up a trigonometric equation. So we have inverse trig ratios. Okay. So here, if sine of A equals 0.5, then what we say is, I want to know what A is, right? That's my variable in this case. Then A equals the inverse sine. So this is called the inverse. It has that little -1 next to it. And then of 0.5. To figure out what this is, all I'm going to do is still just type it in my calculator. Okay? So inverse trig ratios are exactly where our trig ratios are. They're here. Okay? So I have my inverse sine of 0.5. Okay? If these on your calculator are grayed out, please bring the calculator up to me, and I can, it's just because it's in that test mode, I will help get it out of test mode so that you can use the calculator. Okay, so the inverse sine of 0.5, we get 30. So my angle A would be 30 degrees. Okay. Same thing for cosine A. If cosine of A equals 0.5, then A equals the inverse cosine of 0.5. Okay. Same thing, my inverse cosine, same place. Inverse cosine of 0.5, I get 60. I get 60 degrees. And finally, if tangent of A equals 0.5, then, A equals the inverse tangent of 0.5. Okay. And again, typing that in my calculator, the inverse tangent of 0.5 is, we'll say, 26.6 degrees. Okay. So again, those inverse trig ratios are just exactly in the same place. Again, if you have a different calculator, you usually have to hit second and then the sign to get inverse sine or whatever. It's right above where your trig ratios are. All right, so now I'm going to be solving for the missing angle of a triangle. We're also going to look back at things we knew before. If I know two of my angles, then I can just use that triangle angle sum theorem, right? All the angles in a triangle add to 180. If I know two sides, then I'm going to be using our inverse trig ratios. So let's look at our first example. Right here, I know two sides of my triangle. So again, I see where my angle is, right? I'm solving for theta. That's just our variable. I have my hypotenuse, the opposite side, and the adjacent side. Okay, since I'm using trig ratios, I get, again, looking at SOHCAHTOA, I don't know which one am I using. Well, I have a number at O, and I have a number at H. So the only one that uses O and H is sine. The SO part of SOHCAHTOA. Okay. So setting up my trig equation, sine of theta equals opposite over hypotenuse. Sine of, well, theta is just the variable, right? Equals, my opposite side is 1.4. My hypotenuse is 2.1. Once I get here, again, getting theta by itself, I'm using exactly what we did up at the top. Okay? I can rewrite this as, if sine of theta equals 1.4 over 2.1, theta equals the inverse sine of 1.4 over 2.1. It really is following our rules, right? If I'm adding something, if to solve for it, I subtract. If I'm multiplying something, I divide. The opposite of sine is just this inverse sine. So we're still just doing the opposite like we've always done. Okay? So then I just have to type this in my calculator. The inverse sine of 1.4 divided by 2.1. Okay? And I'm going to round to the nearest degree. Theta equals 42 degrees. All right, let's look at example 2. So again, this is one where I have a side here and a side here. So this is, again, 2 sides. I'm using SOHCAHTOA. So we'll start by labeling what we have. All right, here's my angle. I have the hypotenuse, the opposite side, and the adjacent side. So I need to use the numbers I have. Right? So the opposite side does not matter, just the adjacent and the hypotenuse side. So adjacent and hypotenuse is that cosine. So cosine of theta equals adjacent over hypotenuse. So cosine of theta equals, the adjacent is 2, the hypotenuse is 3. Compute this whole board. So then, come on. So then, theta equals the inverse cosine of 2 over 3. Okay. Theta equals, and I'm just going to type that in my calculator. Trig inverse cosine of 2 divided over 3. I get 48.2 degrees. And looking at example 3, if we look here, I don't have any sides. All right, so for this one, I'm going to be using the triangle angle sum theorem. So, right, remember, it's a box, so it's 90, and this is what I'm solving for. So x plus 40 plus 90 has to equal 180. X plus 40 and 90 are on the same side, so I'm just adding them. Then 130 and 180 are on opposite sides, so I do the opposite. So x equals 50 degrees there. Easy enough. All right, looking at example 4. All right, I have, for example 4, I have 2 sides. So since I'm given 2 sides and I'm finding the angle, I am going to be using SOHCAHTOA. So looking at my angle, I have my hypotenuse, the opposite side, and the adjacent side. So I need to use the opposite side and the hypotenuse side. The adjacent side does not matter. So I'm going to be using, sine, right, is opposite over hypotenuse. So sine of theta equals, my opposite side is 13, my hypotenuse is 21. To solve for theta, right, get rid of the sine, I have to do the inverse sine of 13 over 21. So let's type that in the calculator. I have inverse, there it goes, inverse sine of 13 over 21. And I get 38.2 degrees. All right. Example 5. Example 5 is another one where I'm given 2 angles. I'm not given any sides. So example 5 is also our triangle angle sum theorem. So, right, I have x here. So x plus 65 plus 57 equals 180. 65 and 57 are on the same side here, so I have 100. No. which equals 180. And then I'm going to subtract 122 from both sides. So x equals 58 degrees. All right, last example, example 6. All right, again, this is one where I have two sides. So since I have those two sides, I'm going to be using SOHCAHTOA. So here's my angle. All right, across from my right angle is the hypotenuse. Across from my given angle is the opposite. And my adjacent, what sides am I actually using? The opposite side and the adjacent side. So my hypotenuse doesn't matter, so right, tangent uses opposite and adjacent. So tangent of theta equals opposite over adjacent. So tangent of theta equals, my opposite side is 14. So over 19 is my adjacent side. So then to get rid of the tangent, theta equals the inverse tangent let me move this up, see if it writes better. Of 14 over 19. And then just typing that in our calculator, right, trig, we do inverse tangent of 14 divided by 19. And we get 36.4. And that is it. Go ahead, work on D2 activity.